All right. Good morning and welcome to the Quantum New Mexico Symposium. I'm Ivan Deutsch. I'm the director of the Center for Quantum Information Control and your MC for the day. Today we're here to learn why New Mexico is a quantum state and how the second quantum revolution will spur the high-tech economy that New Mexico helped launch and will lead into the future. The Q&M project aims to build on that foundation and to grow the quantum ecosystem here in New Mexico and realize our potential through partnerships between our universities, national labs, and government. So today we're taking the first steps in launching the Q&M Institute, a joint institute between the University of New Mexico and Sandia National Labs in quantum information science. So without further ado, I want to hand over the podium to Susan Seastrom, the Associate Laboratories Director for Advanced Science and Technology and Chief Research Officer at Sandia National Labs, and also to Ido Sarmiloglu, Distinguished Professor and Special Assistant to the Provost for National Laboratory Relations, for their welcoming remarks. So Susan, please.
I'm so glad to be here today. It's amazing to be in a room filled with real people. It hasn't happened to me that often in the last 2 years, but I'm also pleased to be able to welcome all of you to this symposium today. I think you're going to hear about great opportunities in quantum information that will have benefit to New Mexico and impact on quantum information science. I think that there's a lot going on, and you'll hear something about that already. No, okay, that's showing. So, Sandia is intensely interested in quantum information science. Our business is national security, and quantum is a field that can impact national security greatly. It also is a field where there's a lot of need for fundamental advances in research and development, and that makes it really what we think is a sweet spot for Sandia and a sweet spot for New Mexico. At Sandia, we think we do our best when we can bring breakthroughs in physics or materials or computing to bear on creating through engineering technologies that solve problems in national security. And we do that by investing in key capabilities, by partnering with other labs, with universities, and with industry, and by doing what I call team science, right? We do well when we create multidisciplinary teams to solve hard problems. And one of the ways in which we do that is illustrated on the slide behind me. We have identified 7 areas that are core capabilities for the future of all missions at Sandia. Those are called research foundations, and 4 of them are particularly relevant for quantum information. You can see in the upper right, material science, nano devices and microsystems, computing and information science, and engineering science. And I would say our chair at this session, where did he go? Oh, there you went, Ivan. Wrote a paper in 2020 on harnessing the power of the second revolution in quantum information, and he made the point that quantum information is inherently multidisciplinary. To us, that makes it a sweet spot for Sandia. He also made the point that there's a lot of basic science to be done, and we have to build on that, and that makes it a sweet spot for this collaboration. Sandia has some capabilities that we think are differentiating in this regime, and I'll just mention 2 of the things on this slide. One is the MESA fab, which is a silicon fab and a microfab, and which is now a global supplier of ion traps and silicon-based quantum dot devices. And I'll think back to the early 2000s when I was at Los Alamos, and we established there a quantum institute that was sponsored by the physics division and the theory division. And my colleague at that time, Dana Birkeland, had these great ion traps that came from Sandia that she was using, which were on a chip compared to, the macroscopic kind of ion traps that were used. And that's a core capability that is playing at Sandia to this day. And then I'll mention the Center for Integrated Nanotechnologies. So a DOE Office of Science user facility jointly managed by Los Alamos and Sandia with sites at both laboratories. And they call themselves a community focused on nanoscience integration. And it's through integration of devices into real systems that we can have an impact in quantum science. And there are a few recent innovations that have been done by Sandia researchers on this slide, and I'll just mention a couple things. One is, illustrated on the left-hand side of the slide, which is a high optical access ion trap, a surface ion trap that has been micro-fabricated at Sandia and operates at room temperature, so it allows the kind of access you need to impact the state of the trapped ions in order to make them qubits that can have their state flipped. And then recent work in one of our LDRD projects has created a reduced footprint atom interferometer for position awareness in GPS denied environments, has a lot of applications to multiple missions at Sandia. And finally, the Quantum Systems Accelerator, which is one of 5 centers focused on quantum science funded by the DOE Office of Science, where we partner with Lawrence Berkeley and a number of powerhouse university groups, including UNM. And they're focusing on co-design, which means at the same time thinking about algorithms and architectures to create useful devices is the focus. So a lot of stuff going on at Sandia already in quantum information. And I'll just close by mentioning that what I'm sure you're going to hear multiple times today, quantum information science is a national strategic priority with a lot of potential to impact New Mexico's economy. You'll see the quote on this slide from Secretary of Energy Jennifer Granholm, who showed a lot of interest in quantum when she was at a virtual tour of Sandia a few weeks ago, and our own Andrew Landau talked to her about this subject. We hope QNM can catalyze an enhanced role for New Mexico through strong R&D, quantum-ready workforce, and industrial partnerships. So I hope you enjoy the workshop and welcome. And Peter.
All right, Hannah, I'll need your help in finding the slides. Thank you. Thank you very much. All right, good morning, everyone. My name is Idil Shamiloglu. I wear several hats here at UNM, but today I'm here as the Special Assistant to the Provost for National Lab Relations. That's a position that was created in 2017, and the Provost at the time thought that it was important to have a point person at UNM to liaise with the national labs, and I think that attests to the importance that UNM places to its relationship with the labs. I'd like to welcome Vice President for Research Ellen Fisher, who's with us, Vice President for Finance Teresa Constantinidis. I'd like to welcome John Sorrow, Deputy Director for Science, Technology, and Engineering at Los Alamos, and of course, Associate Lab Director Sue Seastrom from Sandia. I would also like to welcome my colleagues, visitors, and all the students who are joining us today. So what I'd like to talk about is what is UNM's role in QNM, but not only QNM, but rather in the whole ecosystem of the state of New Mexico. And my response to that is workforce development. UNM's primary role is to educate the next generation of engineers, scientists, technicians, technologists that can go on to support not only the national labs, but also industry in the state. And I think this is a great opportunity to grow the workforce in the quantum ecosystem in New Mexico. I'm going to briefly describe some examples of what we're already doing to grow the workforce for the labs. A couple of years ago, we established a Bachelor's of Mechanical Engineering program at UNM Los Alamos. There's a tremendous need for mechanical engineers in the state, And by establishing this program up at UNM LA, it gives us an opportunity to grow the workforce that's needed up at Los Alamos. There's a program that Los Alamos is supporting at UNM called the Lannel Accelerator Science and Technology Undergraduate Research Program that supports students that could then go on and do their advanced research at Los Alamos and potentially join the workforce. And I'd like to highlight this is a tremendous opportunity to grow the QNM workforce for Lannel. So there's an opportunity to have a similar program that could grow the quantum workforce by educating more undergraduate and graduate students at UNM. Of course, we have a special relationship with Sandia National Labs. UNM is one of 5 Academic Alliance partner institutions, and we have several initiatives that we've been working on with Sandia. For the last several years, we've had a summer institute called NOMAD, which brings together students and postdocs from around the country to come to UNM, stay at the dorms, and work on challenges in the area of nonlinear mechanics and dynamics. Of course, since the early 90s, we've had the Advanced Materials Lab, which is down in South Campus, which brings together Sandians, UNM faculty, UNM postdocs, research faculty, and students to collaborate. And pre-COVID, every summer, they would host about 30 graduate students from outside of New Mexico who would work and collaborate over the summer. That was an opportunity for UNM to recruit additional graduate students, and it's also is an opportunity to recruit the next generation workforce at Sandia. We are also collaborating with Sandia and AFRL on a new project on South Campus that we're calling the New Mexico Research Innovation Collaborative. It's basically to amp up what's already going on with AML, but to build a larger building between 150 and 200,000 square feet that will house Sandia, UNM, and then AFRL heard about it and they said, we want to be part of it. So this is a project that it's in its nascent stage. We're hoping that it will grow the next generation workforce, not only in material science, but also in directed energy, in advanced computing, but also in the quantum ecosystem. And recently, we've started a program with Sandia, I would say a year and a half ago, called the START HBCU program. And what this program is we're recruiting undergraduate students who are graduating from historically black colleges and universities like Florida A&M, Norfolk State, North Carolina E&T, and Prairie View A&M. We're recruiting them to UNM to come to graduate school. UNM is offering them in-state tuition, so there's a break on the tuition, and Sandia is hiring them as interns. So they take their classes, they spend 20 hours a week during the academic year at Sandia, and they spend full time in the summer at Sandia. And the first cohort is currently going through the system. I already mentioned this. And we also have the Sandia Women's Action Network, SWAN, which brings together, again, this was pre-COVID, but it did bring together female staff members from Sandia and female faculty from the university periodically to have a opportunity to network and socialize. Finally, Sandia is now in discussion with academic advisors in the College of Arts and Sciences, where what they're trying to do is recruit students from non-STEM fields to come to Sandia to work as a technologist, and Sandia would offer the training and the necessary skill set that they would need to be part of the Sandia workforce. And then finally, UNM and Sandia are very close to completing a faculty loan program master agreement. This agreement is similar to our already in place